Alright guys, let's talk about lesson 3B, which is the final lesson for trends in the periodic table. And we're going to talk about trends in ionization energy and electronegativity. I want you to remember what we've talked about when we've talked about reactivity in the past. Metals decrease across the period. So basically what that means is that the reactivity of metals decreases as you go from left to right across a period on the periodic table. Metals increase going down a group on the periodic table. And this is because there is the larger the atom is, the weaker the nuclear pull is, and the more easily you can lose electrons and become stable. So remember, as we're going down a group, the metal atoms are getting larger, so those valence electrons, those outer shell electrons, have a weaker nuclear pull. As you go across a period for metals, the actual nuclear pull is getting stronger, which is pulling those valence electrons in closer to the nucleus, so that makes their reactivity decrease. Nonmetals, it's the opposite. As you go across a period for nonmetals, the reactivity increases. And as you go down a group, the reactivity decreases. And this is because the smaller the atom, the greater the nuclear pull, and the more easily it will attract electrons. So let's look at this in a picture representation. So we have a larger atom here on the left. We have a nuclear pull, but remember this atom is larger, so it'll be very easy to get rid of this electron because this is not as strong, say, as a smaller atom. Here's a smaller atom, positive nuclear center. This is a stronger pull or attraction between the electron and the nucleus because there's less distance there. So let's look at ionization energy. Ionization energy is the first trend that we're going to talk about. It is the energy required to remove the most loosely bound electron. That means that it is the energy required to kick off the valence electrons or to remove them. In your reference packet on table S, this can be located. It's located actually right here, and it's in units of kilojoules per mole. So what is the trend for ionization energy? The trend for ionization energy going across a period increases. Why does this happen? Remember, the ionization energy is the ease at which you can remove an electron. So it gets larger as you go across a period, and that is because there is a strong nuclear pull between the outer electrons and the nucleus, which makes it more difficult to remove those electrons. So again, let's look. We have an element aluminum on the left side of period 3, and we have chlorine on the right side of period 3. Aluminum is a larger atom than chlorine, so it's going to take less energy to remove this electron than it is chlorine. Chlorine has a greater pull between the electron and the nucleus, so it's going to take more energy to pull off that one electron. What happens to ionization energy as you go down a group? As you go down a group, it decreases. Why does that happen? Larger atomic radius means that there's a less nuclear pull on the outer electrons. Remember, as you go down a group, where these valence electrons are going is further and further away from the nucleus. So the further and further away they go from the nucleus, the less energy it's going to need for them to be pulled off because the attraction between the valence electrons and the nucleus is less. So again, let's look at this. We have this very basic sample here. So we have a positive, larger atom. This pull is going to be less because this electron is further away as opposed to a smaller atom. This pull is going to be stronger because it's closer to the nucleus. So how can we use table S to determine the trend in ionization energy? We did this with atomic radius, and we're going to do it with electronegativity, which is the next trend. So let's do this step by step. So to figure it out, what you're going to do is you're going to pick a group or a column and note the values of the element. So what would this look like in a problem? Going down a group, what is the trend in ionization energy? So let's look. So we're going to pick the elements in group 1, sodium, potassium, and rubidium. And then what we're going to do is we are going to look at their ionization energies. So sodium is 496, potassium is 419, and rubidium is 403. This is a cutout from your table S in your reference packet. So as you see, going from 496 to 419 to 403, your trend is decreasing. It's getting smaller. Let's look at this practice question. What is the trend in ionization energy going down the group, and why does this trend occur? Pause the video, answer these two questions, and then unpause it to check your answer. Okay, welcome back. What is the trend in ionization energy going down a group? That trend is decreasing. And why does it happen? Because there is a larger atomic radius, and that means that there's going to be less nuclear pull on those valence electrons, so it's going to take less energy to remove those electrons from the atom. Let's look at electronegativity. That is the next trend that we're going to talk about. So electronegativity is the measure of the attraction for the electrons. Again, that is how easily it is going to be for an atom to gain electrons. So this is located on table S again in your reference packet, and it's going to be next to the ionization energy. So electronegativity, like I said, is the ease at which an element can gain electrons. So fluorine is the most electronegative element. It has a value of 4.0. The closer an atom is to fluorine, the higher electronegativity is going to be, and it ranges in a scale from 0 to 4.0. Fluorine is the highest. So what is the trend in electronegativity as we look at the periodic table? Across a period, the trend is going to increase. Why? That is because there is a stronger nuclear pull, positive charge, to attract the electrons. So as we go from left to right across the period, it's going to increase. Again, why is this happening? In a larger atom, this pull is less. So it's going to be very hard to attract those outer electrons and to bring more electrons into the atom. For a smaller atom, this trend or pull is greater, so it's going to be very easy to attract electrons. What happens with electronegativity as you go down a group? The trend decreases. Why does that happen? Larger atomic radius means that there's a less nuclear pull on outer electrons. So as you go down a group on a periodic table, the trend for electronegativity is going to decrease. Remember, there is going to be a less likely chance as you go down a group. Remember, our atoms get larger. Larger atoms, that pull is not strong enough to grab electrons that are floating out in space and attract them to the nucleus. This, on the other hand, is going to be a smaller atom. It's going to be very easy to attract those outer electrons. So how can we use table S to determine trends in electronegativity? So we're going to pick a row or a group and note the values of the elements, and we're going to look at, for this example problem, we're going to look at going across a period, what is the trend in atomic radius? So we're going to pick an element on the left, we're going to pick sodium, and an element on the right, chlorine, and they're all both in group 3. So let's look at the trend. So sodium has a value of 0.9, chlorine has a value of 3.2. So we're going from 0.9 to 3.2. That trend is increasing as we go across the period. So let's look at practice problem 2. What is the trend in electronegativity across a period, and why does this trend occur? So I want you to pause the video, answer this question, and then we'll come back. Great, welcome back. Hopefully we'll get this right. So what is the trend in electronegativity across the period? The trend increases. Electronegativity increases as you go across the period. And why does this happen? Because as you go across the period, the atoms get smaller, so there's a stronger nuclear pull to attract those other electrons. All right, let's look at all the trends that we've talked about in Unit 3 in one lump sum chart. This is a great chart to have in your notes, and a great chart that I would kind of in a way memorize. So let's look at the periodic property and then the variations as we go across the period and down a group. So let's start off with metallic character. Metallic character decreases as you go across the period. Remember, on the left side of your periodic table in a period, it's going to be more metallic elements, and on the right side of your periodic table in that same period is going to be non-metals or less metallic elements. So that makes sense that it should decrease as you go down a group. Now it will increase as you go down a decrease as you go down across the period, and increase as you go down a group. Now that should make sense because as you go down a group, your atom's getting larger, so you're going to have more metallic character. Atomic radius is going to decrease as you go across a period. Remember, that pull between the valence electrons and the nuclear charge is going to make the atom get smaller. It's going to increase as you go down a group because once you add more and more electrons, those electrons are going to go in other energy levels or shells further away from the nucleus. Ionization energy increases going down a group. going across a period and decreases going down a group. Ion size will decrease as you go across a period and increase as you go down a group. Electronegativity will increase as you go across a period and decrease as you go down a group. Remember, this is a great summary of everything that we've talked about in this unit. Sums it up in one neat, nice, tidy place for you. So let's check your understanding. Let's look at these two questions. I want you to work on these two questions in your notes tonight, and then we're going to talk about these when you come into class tomorrow. So the first one is, what is the trend in ionization energy going down a group? And the second one is, why does this trend occur going down a group?